It is 11:06, so we'll go ahead and get started. So we are on chapter 5, which is part 2 of the volume 1 of the CCNA 200-301 official cert guide library. Um, so the chapter is labeled is called Analyzing Ethernet LAN Switching, right? So what is it going to cover, right? So typically, whenever you get a switch out the box, right, you could just plug it into your network. It's good to go. It'll start switching frames, right? Um, of course, you plug in your Ethernet cables, um, being technical, your unshielded twisted pair cables, and you don't have to figure anything else. Like it's literally, you can plug in and go, right? But part 2, right? The part 2 of this book, it is meant to show you how to configure, how to verify the operations of configuring a switch for Ethernet local area networks, right? So chapter 4, we touched on, using the CLI, right? You guys learned how to move around, use my favorite command, the question mark, um, issue a bunch of other commands and configure some things on the switch, right? So chapter 5, we're going to take a short step, right? That's talking about the logic, right, behind configuring a switch. What are the switch's three main functions? And you guys are going to have to remember that. Um, and breaking down a few things that we've learned already back in part 1, going on to part 2. Okay. So let's go ahead and get started. Okay. So, right. Couple of the things that before we jump in that if you guys are following along within a PDF for the objectives for the exam, here are some of the bullet points from the objective list that this chapter is going to cover, right? So 1.0, network fundamentals. 1.1, explain the role and function of network components, okay? 1.1.b, layer 2 and layer 3 switches. 1.13 describes switching concepts. Okay, so we're going to touch on right how switches learn MAC addresses. We're going to talk about the aging timer. Right, we're going to talk about frame switching. We're going to talk about frame flooding. We are also going to talk about the MAC address table. Right, 2.0, we're going to talk about network access. We're going to talk about 2.5, which is very important. And I say this is very important because if you guys go on network engineer and network security interviews, you will be asked, right, if they're a company that cares, right, and that's my own opinion, if they care about hiring skilled engineers, you will have a technical interview, and they will test you on your knowledge of STP or spanning tree. Okay, all right, so let's go ahead and get started, right? So by default, right? Typically, local area networks, they connect devices to other devices, right? Switches will connect, one will connect to a server, another one will connect to a host, and now we have a client server setup, right? Now the location of these hosts, of these devices, they vary, right? So of course, this diagram you can see we have a campus local area network, and of course, we have a data center local area network. Like I said, some of these switches will connect to other hosts, those other hosts being maybe servers or resource, or you can see that in the data center local area network. And of course, the campus local area network, it'll go ahead and connect, right, to host, right? So quick little tidbit about some of the concepts, right? But let's go ahead and dive deep. And this is one of the key things, right? And I will always ask you guys, what are the three major functions of a switch, right? This is a key topic, and you guys need to repeat this to yourself consistently. Okay. So, and this is the fundamental before you get into talking about dynamic routing protocols. So let's read this word by word. LAN switches receive Ethernet frames and then make a switching decision, either forward the frame out some other ports or ignore the frame. To accomplish this primary mission, the switch performs three actions. Now, this is also called the three major functions of a switch. If you guys Google it right now, you can type in three major functions of a switch and you will see one, two, and three there, right? Number one, deciding when to forward a frame or when to filter, not forward, a frame based on the destination MAC address. Number two, preparing to forward future frames by learning the source MAC address of each frame received by the switch. And number three, cooperating with all switches to prevent the endless looping of frames by using spanning tree protocol. This is the primary function of a switch out of the box. Okay. In production, wherever you, however you want to say it, you want to term it. This is the three major functions of a switch. This is always what it's going to default to. Everything else is extra. This is what you're configuring, but absolutely, these are the three major functions of a switch. This is a key topic for the CCNA. This is a key topic for your career if you decide to become a engineer that works with switches and routers and firewalls. Okay. All right. So we talked about the three major functions, right? So the first thing I want to go ahead and discuss is forwarding known unicast frames, right? So to decide whether to forward a frame, what does a switch have to do, right? A switch has to build a table that lists all the MAC addresses and the outgoing interfaces, right? So, right? So what happens, right? So the switch is going to go ahead and look at the frame and say, the destination MAC address, right, doesn't, right? I see this MAC address within my MAC address table. I know where to forward this. I'm going to forward this out of this interface. Okay. So now I'm following that logic of the primary functions of the switch. Okay. So let's go ahead and read this logic real quick, right? This sample. So switch one, right? I see Fred is sending a frame and the destination is ending, right? .2222. Okay. So step one, right? The frame came in on fast Ethernet 0/1. Okay. Right. So the switches, if we're talking about the logic, right? I'm going to go ahead. I know if we look at number two, we are preparing to forward future frames by learning the source MAC address of each frame received by the switch. I know now, right? I know where Fred lives, right? I know Fred's MAC address, right? I know that now. So it's Fred's MAC address is .1.1.111. That's his MAC address. So I fulfilled, if I'm the switch, I fulfilled that job that I'm supposed to perform, which is number two in that primary function of the switch, right? If we go ahead and go to step two in this list, right? And I see destined, this frame is destined for 2.2.2.2. Okay. In my MAC address table, that location is known. It's right off of fast Ethernet 0/2. So now I can go ahead and forward that, right? I'm going to forward that out of fast Ethernet 0/2. Now, going back to the logic, right? The primary functions of the switch. I now know where to decide on where to forward this frame. Fast Ethernet 0/2. Excellent. I'm going to go ahead and forward it there, right? But also, with that logic, I also know where not to forward that frame, aka filter. That's step number four. I'm not going to send it fast Ethernet 0/3 and fast Ethernet 0/4 because it's not meant for it, right? Okay. This is the logic of forwarding known unicast frames. Because why? My MAC address tables knows where right, knows where to forward it. Simple as that. Okay. Quick note, a switch's MAC address table is also called the switching table or the bridging table or even the CAM, right? The content addressable memory, right? For the exam, you will need to know, right, the other names for a MAC address table. Another name for a MAC address table is the CAM table. You will be tested on that. You will be tried on that. So please understand the difference. Okay. So, right. So we talked about, right, we talked about how, how the logic works. I'm not going to go over it again. This diagram goes over the same thing, right? But now we just added another switch, right? So Fred, right, now he has a new destination to 3.3.3 dot 3333. Excuse me, I apologize, right? And so switch one MAC address table, right? It knows how to go ahead and get to dot 3333, right? And I'm referencing the last four digits, right? It knows to send that out of gigabit 0/1 on switch one, right? So I'm going to go ahead and send that, right? I'm going to send that to switch two. Switch two is going to go ahead, use its logic. It's going to go ahead and forward it, right? It's going to go ahead and forward it. It says, hey, destination for dot 3333. It has it in its table, and it's going to go ahead and forward that frame. Okay. All right. Simple enough, right? Now, this logic that I'm showing you is for known unicast frame. Why is it called known unicast frames? It is called known unicast frames because the MAC address table knows the MAC address for the destination. Okay. All right. And the destination address is a unicast address. That's the other piece. Okay. All right. Let's keep going. Now, quick little tidbit, right? Quick little note. The term forward versus filter decision emphasizes the switcher's choice to forward the frame out of some ports, but not forward filter the frame from being sent out other ports. Okay. All right. Let's talk about how that switches learn MAC addresses. Right. So, right. Thankfully, right, we don't need to manually type in MAC addresses, right? Because if we had to do that, Jesus Christ, I probably need to get paid more, right? So thankfully, we don't need to do that. Switches now have the ability, right, to learn MAC addresses dynamically, right? And if we're talking about the three major functions of the switch, right, its major function is to one of the major functions is to learn about MAC addresses, right? Based on the source, the source MAC address of where it received the frame from. It's going to log that MAC address within its MAC address table. Okay, right? So that switch, right? Let's say Fred is sending a frame, right? Sending a frame, right, out of its interface on its PC. Let me get my pencil so it can help out, right? So Fred is sending this out, right? He's forwarding it to the switch. What the switch is going to do, the switch is going to say, hold on, right? I want to go ahead and send a frame, right? I want to send a frame over to Barney, right? Dot 2222. But what the MAC address table is going to do is going to say, hey, I'm going to go ahead and lock in this MAC address, right? And I'm going to lock in the interface where I learned this MAC address from. Now I'm starting to build my MAC address table, right? And what's going to happen is it's going to go ahead and say, hey, and we haven't got there yet, but I'm gonna skip a little bit ahead. It doesn't know where Barney lives at yet. Okay. It's going to go ahead and broadcast that frame that Fred sent out of all ports. And this is unknown unicast frames. Okay. So it's going to go ahead and forward it. Once we get a response, boom, erase that, cut that out. Now we know the switch knows it it knows where Barney is, right? Off the fast Ethernet 0/2. It knows where Fred is. Fast Ethernet 0/1, right? You guys are probably thinking, okay, Dave, if we sent a broadcast message and it went out all ports, why didn't the switch learn about Wilma's MAC address or Betty's MAC address? Well, we didn't get a response back, right? Because that destination wasn't meant for Wilma or for Betty. They received it, but that host, that NIC on their computer, they dropped it because it wasn't meant for it. So there was no response back. We only got a response from Barney. Okay. All right. Let's keep rolling. Okay. Now, let me do this 1 second. Pulling up my notes, guys. Sorry about that. I want to make sure I stay on track so I don't miss anything. Okay. So I don't have a diagram or a picture for this, but we're going to take a sidestep and talk about flooding unknown unicast and broadcast frames, right? Now, let me get my pencil again. Let's cross this out. Let's cross this out. Let's cross this out. Okay. So, and I wanted to cross this out for a reason. So we know if Fred is trying to send a frame, right? And there's no entries, right, in the MAC address table, right? There's nothing matches it. Okay, nothing matches it. There's no matches. What the switch is officially going to do now, guys, stay with me. It is going to forward the frame out of all interfaces except for the incoming interface where it received the frame. This is the process that I just explained is called flooding. I'm going to say it again. If there is no matching entry in the MAC address table for a destination MAC address, the switch will forward the frame out of all interfaces except for the incoming interface as to which it received the frame. This process is called flooding. Okay? And the frame whose destination address is unknown to the switch is called an unknown unicast frame, or simply just an unknown unicast. Okay? Keeping it simple, switches always flood unknown unicast frames. Okay? Again, flood means it's going to forward, right? The switch is going to forward copies of the frame out of all ports, except for the port that it received it on, until we get a response, right? Because typically all traffic, we need a reply, we need acknowledgement, or what have you, right? And so then the switch is going to go ahead and learn both, as you guys see in this diagram. It's going to learn that MAC address and lock it in its MAC address table. Okay? But let's talk about another situation, right? There's another type of frame as to which a switch will flood out of all of its ports. And this is for broadcast frames. Okay? All right. I need you guys to remember this for the exam. Frames that are destined to Ethernet broadcasts have a destination MAC address of all F. Okay. Right. So, of course, MAC address has 3 octets if we're talking about decimal. Right. So each character within the octet, right? Each octet has 4 characters, right, in decimal form. each character is going to be an F. Okay. So any type of broadcast is always going to be is the destination MAC address is going to be all Fs. It's going to be forward out of all interfaces. Okay. All right. And of course, these broadcast frames, they help deliver a copy of the frame to all the devices within a local area network. Okay. There's specific technologies that we spoke about, ARP, um, and some other technologies that we spoke about earlier that does some type of broadcast, some broadcasting with it. Okay. So let's go ahead and let's move forward. Let's talk about one of my other favorite topics. Okay. Let me go ahead and erase this. Right. So the third primary major function of a switch is loop prevention. Okay. And how that's achieved is by spanning tree. Right. Without spanning tree, exactly what you guys see here. The frames would be flooded, right? Continuously flooded throughout all ports, right? Continuously, right? So as you guys see, we start at Larry. If we don't have spanning tree implemented, Larry's going to go ahead and send it here, right? He's going to send it to this switch. The switch is going to send it back to the switch that Larry sent it to. Just going to keep going and 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 keep going, right? And what we have now is a broadcast storm, right? And now your switches are going to halt, right? What we see in our topology here is we have redundant links, right? The core thing here with spanning tree is it enables, right? It enables, connection on redundant links without loops, a looping, an indefinite loops of frames within that topology. Okay, so sorry, just got a message. So we don't want flooding to happen. We don't want flooding to happen within our within our architecture, but we also want redundancy, right? So if my Kivia has, right, three switches, just like here, right, and she has a redundant setup, what spanning tree allows is, right, we have all three connected to each other, right? This port is forwarding, this port is forwarding, this port is forwarding, this port is blocking, right? This port is forwarding, this port is forwarding, right? What we can see is anything is going to go one way, right? Right? And so if something happens to this switch, right, maybe just to that interface, we can still reach Archie from Bob. He can just go this way, right? If we go ahead and fix that, we can reach Archie the original way. Okay? So we're able to have redundancy at a layer two level. Okay. All right. Again, the flooding process that we just spoke about, it's a great mechanism. It helps forward unknown unicast and broadcast. But of course, if we don't have any mechanisms to go ahead and resist that flooding to our redundant links within our topology, again, we're going to create a broadcast storm, and um, spark the CPU within all of our switches, and of course, unfortunately, halt our switches and stop our network traffic. Okay. Chapter 9, we're going to speak about spanning tree concepts, but we'll get to that in the future. Okay. So let's keep going. Um, so key topic here, right? And this is going over some of the logic that we spoke about so far. So let's read it step by step, right? So step one, right? Switches forward frames based on the destination MAC address. Right? I know this sounds familiar. A, if the destination MAC address is a broadcast, multicast, or unknown destination unicast. Okay? The unicast is not listed in the MAC address table. The switch floods the frame. Okay? Outside, right? The second part of step one, right, is B. If the destination MAC address is known, right, is a known unicast, meaning that that MAC address is within the MAC address table, right? It's either going to A, if the outgoing interface listed in the MAC address table is different from the interface in which the frame was received, the switch forwards the frame out the outgoing interface. Two, if the outgoing interface is the same as the interface in which the frame was received, the switch filters the frame, meaning that the switch simply ignores the frame and does not forward it. Okay? And this is all just within step one of the switch's forward frames based on the destination MAC address, which is one of the primary functions. Step two, switches learn MAC address table entries based on the source MAC address. Okay? Hey, for each received frame, what the CPU does within the switch is it saves, right, the MAC address with the corresponding incoming interface ID for the port. Okay? B, if not yet in the MAC address table, right? So meaning if there isn't an entry for the MAC address within the MAC address table, we're going to go ahead and add that to the MAC address table and the incoming interface. Okay? One of the other major functions of a switch. Last but not least, step three, right? Switches use spanning tree protocol to prevent loops by causing some interfaces to block, meaning they do not send or receive frames. Okay? So one of the things that we spoke about in chapter 4, whatever we were talking about command line interface, is that we can use some commands to verify, right? And of course, analyze our switches or what have you, right? I told you early in the beginning of this chapter, any switch out of the box, right? If you're just plugging into a simple network, you can just plug and play, right? Out of the box, I'm gonna give you guys, and of course, this is for the exam and for your career as well. I'm gonna tell you what the functions of a switch would be out of the box. Okay. So by default, here are the default settings. All the interfaces are enabled by default on a switch. Okay. All the interfaces out of the box on a switch will be assigned to virtual local area network 1 or VLAN 1. Okay. Interfaces, right? They're going to use auto negotiation by default. And this is in regards to speed and duplex, okay? Right? The logic that we just spoke about, as far as MAC address learning, right, and forwarding and the flooding logic, all of this works by default. You do not have to configure it, okay? And of course, spanning tree, right, STP, this is enabled by default. I need to make a point. This is only in regards to Cisco. Okay. All right. I need you to just remember this just for Cisco. I've engaged with other vendors that create switches, and you guys will be surprised that spanning tree is not enabled by default. I was shocked too, but that's just the way it is. Okay. So let's keep talking more about it. The rest of these slides, they're going to talk about how a switch works with those default settings that I just spoke about, right? So we spoke about and we talked about how the switch learns MAC addresses by one, the destination MAC address, and by this source MAC address of incoming frames, right? So, and let me clean that up what I just said, right? The switch learns MAC addresses based on the source address of incoming frames. right? What I mean by that, right, is if I go ahead, if I'm sending a frame to Gary, right? Gary's destination MAC address, right? It's known, right? It's unknown. So of course, the switch sends the broadcast. Gary's PC responds to my original message. The switch is now going to learn Gary's MAC address based because now he's the source and now I'm the destination. Okay. As you guys can see, here's an example of the MAC address table and all the entries that it learned dynamically. The term dynamic means it learned those MAC addresses, right, by the matter of the logic that we talked about earlier, by traffic passing by the source MAC address. Okay. All right. So, Max, I saw your question. We'll talk about that at the end of the section. Okay. All right. So let's go ahead and keep going. All right. So let's talk about the interfaces, right? Um, we spoke about, CLI in the last section, right? And we spoke about, um, yeah, we spoke about the CLI, and I harped on you guys about verification. Verification is a big thing, right, for layer two and layer three, and for so on, even when we were talking about firewall, right? Now, there's some high level commands, what I like to call them, and there's some low level commands, right? Let's say you guys just want to verify layer one and layer two, right? Or you want to just verify there is a connection on the switch, right? You can do a show interface status. It is going to show you what's connected, what's not connected. It's going to show you the VLAN. It's going to show you the duplex. It's going to show you the speed. It's going to show you, of course, the type, right? The type being either if it's a 1,000 base T or 100 base T or a 10 base T. Okay, right? So other things that we can go ahead and do, right? If we want to go ahead and find entries, right? And again, there are some low level commands, there's high level commands. When you guys are going through this book, there's multiple chapters that talk about the same thing, but they're going to show you different ways because there's always different ways to verify the command. Because here's the crux of the matter for show commands, right? For verification commands, you have to understand what you're looking for. You can't just randomly just put in commands and you're not understanding what you're looking for. Okay. This, we're talking about this at layer two. This is going to be more prevalent whenever we get to layer three, when we're talking about OSPF, when we're talking about um, BGP, we're talking about eGRIP, we're talking about a lot of things. A lot of commands can show you a lot of the same thing or different things. You have to understand what you're looking for. Okay. So this screenshot, right? Let's say we want to find an entry, right, within the MAC address table, right? Because typically, if we have a network, we have a local area network within a business, there's going to be a lot of hosts that connect to our switch. Hell, even if a lot of the hosts are connected via wireless, and there's a whole bunch of APs that connect to these hosts that are connected to the switch, we're going to have huge, a huge MAC address table, right? So, what are some of the ways we can go ahead and find um, these entries, right? First things first, as you guys can see within the screenshot, you guys can see we can use show MAC address table dynamic address and then the actual MAC address. What it's going to provide us, if that entry exists, is going to show us, right? If we break down this command, it's going to show us the MAC address table, only dynamic entries and the entry for this MAC address. That's where the address and of course the MAC address comes in. Okay, let's keep going. Now, there's another way, right? We can do the show MAC address table dynamic interface fast Ethernet 0/1. When would this come in handy, right? So let's say, like I just told you, we have a switch, but we also have an AP that's plugged into the switch, right? And we have multiple hosts that are connected to this AP via wireless, right? So let's say we wanted to see all the users that are connected to a specific AP. Of course, there's different tools and what have you, but at the lowest of level, what um, what Max can do if he was the engineer here, he can do a show MAC address table dynamic interface in the interface that the AP is hanging off of. It's going to show me all the MAC addresses for that interface. Pretty cool stuff, right? Let's keep going. Last but not least, right? We can create virtual local area networks on a switch. We can assign these to ports on a switch, to interfaces on a switch. Okay. If we want to look at all the MAC addresses within a virtual local area network or a VLAN, we can do that. We can say show MAC address table, dynamic, the VLAN and the VLAN number. Okay. Make sure you remember this. Okay. Let's talk about, managing the MAC address table. Okay. First things first, right? MAC address table entries don't stay in the MAC address table forever, right? By default, the CPU, right, the switch is going to go ahead and remove entries that have not been used for a defined number of seconds. By default, out of the box, it is going to remove those entries after 300 seconds. Okay? That is where that aging timer comes in. Okay? What happens is if the switch receives a frame within the 300 seconds for a MAC address, it is going to keep resetting that timer. Okay? For that MAC address. Okay? Now, as the administrator, you guys are able to go ahead and change that aging time, right? And that aging time is set in seconds. Okay? All right. So you guys are probably thinking, right? Why is the last part here highlighted, right? Of course, we talked about the switch removes its old entries or what have you. And of course, the MAC address table uses content addressable memory, right? Content addressable memory, it is actually physical memory, right? That's within the switch, right? Of course, the CAM, amazing table lookup capabilities, right? It's like a SQL database. It's like the little cousin to a SQL database, right? Very powerful, but of course not as powerful as a SQL database, right? So if we ever get to a point to where the total amount of MAC addresses, MAC address entries that are filled within the MAC address table, right? So we see here total MAC address space available 7299. If we hit 7299, right? We're trying to go above that, but of course that switch can't learn no more, right? And maybe, right, these entries, these connections are still within the 300, right? The 300-second mark, right? And it's just about to expire. What you can always do is the switch has commands where you can manage it and clear out the MAC address table, right? You can either clear it by VLAN, you can clear it by interface, or you can just clear it by the straight up MAC address. Here are the commands to do that, right? And this would be done within privilege mode. Okay? Take note of this. Okay? All right. Last but not least, right? Um, let's talk about connections to multiple switches, right? We spoke about how switches learn MAC addresses. We talked about forwarding. We talked about flooding. We talked about spanning tree, right? Um, of course, switch one, if it wanted to learn about, and we'll just talk about this topology now. If switch one wanted to learn about Wilma and Betty's MAC address, right? It's going to have the entry for Wilma and Betty, but it is going to have an interface entry for Wilma and Betty off the same interface, which is going to be gigabit 0/1. Okay. All right. And it's vice versa for switch two, right? For Fred and Barney on switch two, different MAC addresses, same interface. Okay. This is just an example of how it's going to look like if you have multiple hosts on one switch and multiple hosts on another switch, and those two switches are connected. Okay. With that being said, we are at the end of chapter 5. Any questions?
I think you kind of answered mine at the end, far as the switches, and because my thing was like, if say like for switch one, if Fred and Bonnie was connected, and I know that you were speaking on the known unicast, it automatically picks up that MAC address. But when it's multiple switches, that's when they go into a unknown unicast state where it got.
No, so that's a good question. Remember, it's only in an unknown unicast state in regards to the switch whenever it doesn't know about the MAC addresses. That's it.
Got
So
you.
so unknown unicast is only defined by the switch, not the host.
Got you. Okay.
Good question. Any other questions?
Yes, Mike. Sorry.
Uh,
Yes, Dave, I have.
mhm.
Actually, I don't know who else I was speaking here. Um, this is regarding the clearing the MAC address. So my question is, does clearing MAC address from an interface or a VLAN forces the interface to relearn those MAC addresses again?
The interface or the MAC address table?
Uh, MAC address table.
Okay. Yes, it would. Because the MAC address table no longer knows what MAC address hangs off that interface. So if, right, host on a network wants to communicate with that host or vice versa, the host is going to have to communicate. Switches only learn MAC addresses based off of the source and the source, the source address of the incoming frames that are coming into a switch. So we'll need to communicate again.
Okay. Thank you. Just a follow-up question on this.
Mhm.
Does clearing a MAC address on the MAC address table for the interface, interrupts the like a network connection for the device while it relearns?
Absolutely. But it's millisecond. But it's milliseconds, right? So it shouldn't be that big of an interruption. Now, and of course, we'll talk about this in the future. It depends on the device. It depends on the type of traffic, right? Because if you have the type of traffic, maybe you have, let's say you have UDP traffic that's passing through, and let's say it's a phone, right? Phones typically operate on UDP, right? And you clear the MAC address table, right? And an end user is just on that phone. You are going to end the phone call whenever you clear the MAC address table.
Understood.
Okay. So, but that's UDP traffic. TCP traffic, of course, it has error correction. So it's going to go ahead and fix itself. Okay.
Makes sense. Mhm.
All right. If we're talking about a ISP connection, right? If you clear the MAC address, that's fine, right? It's gonna again do its term. It's gonna say, hey, I'm gonna do a ARP. Who are you? Learn your MAC address. Excellent. I'm gonna send it out, right? Now the traffic behind that layer 3 boundary, how it performs is up to, layer 7 of each of those hosts. Okay. However, the developers built each of those programs at layer 7 of how they have to communicate at each layer, what have you, then it's up to them. It's up to them of how it reacts to you clearing that MAC address entry. If it needs a stable connection or if it doesn't.
Thanks, Dave.
Mm-hmm. No problem. Hopefully I answered your question
You did.
hopefully it adds value. I did want to take a second and to answer Max's question. He stated in the chat, good thing Cisco enables STP by default. Was there a reason the others don't do that by default based on your interactions? Currently, my experience level, I've dealt with only 7 types of OSs. It has only been 2 OSs to where I had to enable spanning tree. Um, I had to go ahead and enable spanning tree, and I wrapped my head. Took me. I mean, I was frustrated. By the way, it took me a long time to wrap my head around it. I have not looked at the reason as to why, so I'm not going to guess or tell you the wrong thing. Just know, um, sometimes it's not enabled by default. This is why you guys will see me. It's a habit for me now. Before I go ahead and start working on a switch, I will do a show running configuration to see what does it look like out the box, what's running or what have you. And that's also why in the beginning of this chapter I said this is in regards to Cisco. I will continue to say that throughout these sessions. I will continue to say that even in a professional standpoint, because again, every vendor is different, and I don't know if they mirror each other. Okay. All right, guys. Well, if there's no other questions, I'll go ahead and stop here. And you guys have a great day.
All right, you too. Thanks, Dave.
All right, guys.
Dave.
Everybody.